What is up, everybody? It's Evan Bacon. Today we're going to be picking up where we left off last time. We're going to be showing you how to build the terrain, that mesh that we see. Let me just show you this right here, beautiful, and the ambient occlusion that is associated with it. I'm going to show you quickly how we reference this. We reference it as this.world is assigned new world, and then we send in the world size, whatever we want the chunk width and height to be. I'm not sure how well I coded this. I'm pretty sure it's poorly. So let's just keep this as the same size right now. I'm pretty sure the size is 200. So you get a nice big world out of this to mess around with. You don't really even need to worry about chunk loading right now because it's so big. So let's go over here to that file, JS, this world. All right, so this is kind of a meaty file. So we're just gonna jump really quickly into it. I'm gonna refrain from editing the code while we do it. Again, it's a little messy. You see, we're gonna import this improved noise JS library. And this is purely JavaScript. It works really well in React Native as well. So I'm gonna link you guys to this. You won't want to download it, put it in your JS file like this. Then we're gonna reference it over here. You see, then we just bring in like 3 Expo React, and then I'm not too sure if we need that stuff, but we're gonna have it anyways. So then we have our 3 view. We're using that for loading textures from assets. Over here you see we have our width and our height, that is of the world, and then we're gonna have our Perlin data and the actual 3JS mesh. So in our constructor you see we have width and depth. We're gonna assign those. Then we're gonna do this.data is assign generate height with our width and depth. So I made these functions. This is very functional apps that you can kind of get a lot of self-explanation from that, because I'm a terrible teacher. So we have our data implemented here, then our Perlin, we're just going to reference a new instance of improved noise, and then with our size, we're going to do width times height, and our quality will be 2, math.random times 100, and these are just used for our Perlin function. You see we're going to have a for loop over here, j through 4. This is in reference to the height of the terrain, and you see we're going to kind of burst in through here, creating our Perlin function. A lot of this is super generic. Perlin data initialization is kind of like what's recommended to do with improved noise, so I won't touch on it too much. Essentially what we're doing is we're iterating through our Perlin. If you imagine like a picture of a cloud maybe, then think of like where it's lighter and darker. This is referencing the X and the Y, and whatever color that point is on that cloud picture, that will reference how tall the Z should be, or the XZ, and then how tall the Y should be. Anyway, so we're generating our height, and we're setting that as this.data. And that kind of completes what we're doing here with our variable initialization. If we hop back over here to scene, you'll see that then we want to create our mesh. So to do our mesh, we're going to do an asynchronous function, and we're calling this.world.getGeometry. The reason it's asynchronous, and I'll show you that here in a second, is because we are initializing the texture in this as well. Now, I would actually recommend, if you're doing this, trying to improve on this, maybe making a pull request for me, that we bubble up the texture loading to the topmost level, this kind of main.js. If this.mesh, we're going to return this.mesh. This is just like a, what's it called, lazy loading. This is the lazy man's lazy loading. For JavaScript, I'm going to await and do build terrain. This is the asynchronous method, and then this.mesh. Get geometry is kind of just like a lazy method. And over here, build terrain, you see we're going to do texture asset is assigned expo asset from module, and then we're requiring where our image is. And this will create an expo asset reference to that image. And then over here, you see we're creating an await, and we're doing a texture asset download asynchronously. So essentially we're referencing it, then we're going to wait until it's done downloading, and then we'll continue on with our lives. This.texture, 3view texture from asset, texture asset. This is just creating the reference to the texture image that we loaded in earlier. And then we're going to set our mag filter and our min filter. These, the reason we're setting it to like nearest filter and linear map linear filter is because it's a pixel image that's really small, and so when we expand the image, we don't want it to try and like smooth it out and blur it as we might with like a picture of a man's face that we're like blowing up 100 times its size. With pixel images like Minecraft, we want to keep those as crisp with as solid lines as possible, so we're using these 2 filters particularly because they work really well for that. And this image over here, let me show you what that is. In assets, images, which is kind of where Expo wants you to put your images, or where they recommend it. We have this material PNG. You see this is really small, so let's zoom into this real quickly. You see this is just like beautiful pixel art. And this is 2 texture squares right here. We've got the top of the block and the side of the block. And you can do anything, any texture that you want in here as long as it is this size exactly, because we're referencing it as 2 separate textures. So we're going to call our build terrain with the texture, even though we made it a global variable. Again, not the greatest code. You see we're creating the size of our block, and for this we're setting it to 100. It could be just 1 if you want, and then we're creating half of it just because we're doing a lot of referencing to half of it. Makes it a little bit faster. And then over here we're defining some 3 colors. We got our light, which is pure white, and then our shadow, which is like this grayish color, and then a matrix that we're going to be reusing a couple of times. So over here what we're doing next is, and make sure you type all this out yourself, is we're creating each one of the faces individually, because in past tutorials you've seen where I've made kind of voxel things with like scene kit. I've just made full out cubes, and that creates a lot of unused faces, vertices, edges. It's just a nightmare. So doing it this way is exactly kind of how they do it in the actual Minecraft application. This just gets us what we see on the screen and nothing else. This is like the best way to do it. Maybe not code-wise, but methodologically. Anyways, so we create a plane geometry, and you see we're setting it to the size we defined earlier. See, for our faces, for the vertex colors, we're going to set them as light, shadow, light, shadow, shadow, light. Essentially what this is doing is, if you think about like the texture vertices, those will assign like where the image is, and then these vertex colors will decide like how they're kind of tinted. And so this gives us a really convincing shadow light effect on all those images. This is a really good way to do it. Then you see with our Vertex Uvs, we're setting these particular ones to set them right in the middle for the Y. This is the PX geometry as opposed to the NX geometry. So I'm trying to think how to explain this. A lot of this I would just recommend kind of copying and pasting it in. If you get the general concept of it, this would be like the front face and the back face and top face and then the bottom face. And then later we'll construct using all these different faces, but we want them to be all the same. So everything that has sun hitting it from the east will be, colored like as if the sun was hitting it from the east. Over here you see, then we're going to set our rotation and our translation. If you imagine these as like a square, just imagine a square and then move it over halfway on the x coordinate, and then we're going to rotate it m pi divided by 2, so like 90 degrees. I think you get the idea. And then we're going to do the opposite of that over here, but we're going to keep these the same. So then you see we're doing that on our rotate x as opposed to rotate y, or translate to y as opposed to the x, and we're just going to do that for all 6 of these. Over here you see that this is going to be our world half width, so we're going to take the width, the total width, which is at this point 200, and then we're going to just assign 100, and then whatever our depth is, which again is 200. And then we're going to get this get y function, which will tell us if we give it the x and the y, if you think of it like x and y, like if it was Battleship or something, as opposed to x and z, which it really is. If we give it 2 coordinates, then it will return us whatever the y is for that Perlin generation. You'll see a little bit more about what that means in a second if you didn't get that. And then we'll have our total geometry, which is what we'll be appending these faces to. For our z in the depth, and for our x in the width. So you see here we have our h, which is the height. We're going to do our get y given the x and the z. So if we find where this function is referenced right here, you see we look at our data and then we do x plus z times width, and then that we're going to multiply times 0.2, which is our scalar, and then we're going to give it the optional or 0 if it can't find that data. And essentially this is looking through the Perlin generated data that we made earlier, and it's seeing like which value lives at that xz position. So when we get our height, we're going to translate our context over. You see we're doing x times size. Essentially we're just multiplying it by whatever size we want the block to be, And then with this on the X and the Z, we're moving it so that the center of the mesh is at 0, 0 as opposed to the first block being at 0, 0. If you delete these, then the first block will be at 0, 0. Over here, we're going to be getting these kind of neighbor vertices. See, we're getting the 8, so all of the different corners. And then we're getting whatever the Y is. So if we were to take, like, what's the next blocks over in the X direction and the Z direction, what's the Y value? And then over here, we're going to be doing some, defining some more values by looking at these and comparing the height, and doing either a 0 or a 1. Essentially, this is helping us determine which faces need to become visible here in a moment. Then over here you see if A plus C is greater than B plus D. Essentially, if this is the face that, if this face is visible, then we want to take and make these colors, and we're going to assign it to our pi 2 geometry with this context, and then we're going to merge it into our total geometry. And we're going to do that for all the sides of the cube for this mesh. This is all pretty straightforward. You see a lot of it is duplicated code, just kind of covering these main cases here. When it comes to voxel related things, you'll run into a lot of these things which seem like we're not keeping it dry at all. Anyway, so you see after we iterate through all the values, we're going to get the optimal mesh. We're going to be merging it all, and then we go to this .build mesh with geometry and texture. This is just a function describing what it does, because we got to keep one function for one function. We pass through the geometry and then the texture, and then we see that we create a 3 mesh with that geometry that we made earlier and with the texture that we're going to build here. Again, it's just another like wrapper function, and we're creating a mesh Lambert material, and we're mapping this image with 3 vertex colors. Essentially, we're defining what color type to use, and then when we map the image, because of the way we size the image, this will wrap it so that everything lines up perfectly. Anyway, so when we get to this build texture part, then we do the mesh, we assign it to this global variable, and then finally we get out here and we assign it to this .mesh. Anyways, after that, then we're going to call this .scene add world, and then we're going to add this .mesh to the scene, and then it should render on your screen. It will be great. You will see this terrain being rendered out. You won't see the beautiful sky or the D-pad yet, and you won't have any way of kind of rummaging around it, but you will have the ambient occlusion going on down here. You see my little speaker giving you feedback, and you will see, of course, the beautiful terrain generation. Anyways, thanks so much for watching, and in the next part we will be covering the gesture control system. 2 separate textures, kind of as a sprite sheet, if you're familiar with 2D, whatever you call this thing that I'm doing, programming. It's just kind of better for this, conversion of C to J, blah blah blah. I'll cut all this out of the video, or I won't.